How can water curve on a round Earth? How can water curve over the round surface of the Earth? Great question. This is one of the most common doubts people have when they start thinking about Earth's curvature. Let's break it down step by step in a way that's fun, easy to understand, and just a little bit epic. Doesn't water always level out? Yes, it does, but here's the twist. When people say water finds its level, they usually imagine a perfectly flat surface. But in reality, water levels itself according to gravity, and gravity on Earth doesn't act in a straight line everywhere. Instead, gravity pulls everything toward the center of the Earth. Gravity is the key. Imagine standing in 3 different places on the planet. In Brazil, gravity pulls you toward Earth's center. In Australia, same thing, but from a different angle. In the middle of the Pacific Ocean, it's still pulling you straight down, toward the center. So when water levels out, it's actually creating a curved surface, where every drop is being pulled toward the core of the Earth. This is why oceans curve around the planet. They're not defying gravity, they're obeying it perfectly. This curved water surface is part of what scientists call the geoid, the true gravitational shape of Earth. Real proof that water curves. Yes, we can actually see that water curves with the Earth. Here's how. Ships disappearing over the horizon, they don't shrink, they vanish bottom first. Why? Because the ocean curves away from your view. Satellite images. They show our planet wrapped in deep blue oceans that clearly bend along the spherical surface. Geodetic science. We use satellites, lasers, and GPS systems to measure Earth, and they all confirm the curvature of the sea over the globe. But why can't we see it with our eyes? Because Earth is huge. The planet's circumference is over 40,000 kilometers, about 25,000 miles. That means the curvature is very gentle. Over small distances, like standing on the beach, you don't notice it because you're seeing just a tiny part of the curve. It's like standing on a giant basketball the size of a planet. The surface around you looks flat, but step back far enough, and the roundness becomes obvious. In the end, water does curve with the Earth because it's pulled by gravity, which always points toward the center of the planet. That's why seas, lakes, and oceans gently wrap themselves around the globe. So the next time you look out over the calm sea stretching toward the horizon, remember, you're looking at part of a magnificent sphere, a blue jewel in space, held together by invisible forces older than time. You are standing on the surface of a spinning miracle.